Thank you. So I spend a lot of my time thinking about sandboxes. I have a 2-year-old son, and when he wakes up in the morning on weekends, the first thing he wants to do is get dressed and go out into our garden and grab his shovel and bucket and his plastic ice cream cones and start filling them with sand. I get served sand ice cream and sand cakes and sand sandwiches, but this isn't really the reason I'm here. I'm here because I also spend my weekdays talking about sandboxes and thinking about them. So I work at Modal, which is an AI infra company based in Stockholm, New York, and San Francisco. We're most known for our serverless functions that basically make it very easy to run any Python code in the cloud, and especially on GPUs, and a lot of GPUs if you need that. But we have another lesser known product, which is the one I'm going to talk about today, which is Sandboxes. And we're a relatively small company. We're like 100 people now. We were only 40 when I joined less than a year ago. So growing pretty quickly. Oh, here we go. Sandboxes is one of our fastest growing products. It's basically a new type of AI infrastructure primitive. So my goal today is to convince you all that sandboxes are the most exciting infrastructure primitive coming up for AI use cases, and teach you a little bit about what they are and how they can be used. So first, I want to explain what a sandbox is. I think that's a pretty important thing to get right from the beginning. So let's talk about an example. So let's start by building a coding agent. It's not too hard these days. We can rely a lot on existing APIs. So in this case, we'll use Anthropic APIs. And we'll do something like this. So we'll send a prompt. We get some sort of code back. And when we get it back, we run it as a Python sub-process. Does anyone see any problems with this? There's a few. So what if Claude returns this? Or basically anything else? Like, that's the problem with AI-generated code. You never know what you're going to get, so you don't know what code you're going to end up executing. And that's the fundamental problem. You need to kind of have a good isolation boundary if you're going to run code that's generated by an LLM in which you really have like no control over how it got created. And you might think that this is easy to solve for. You just run this in like a Docker container and you'll be fine. But the truth is that's like not going to give you anywhere near the level of isolation that you would need to properly protect from all the things that AI-generated code might do. And it gets even worse. So like, let's say you pick a better isolation technique. I'll talk more about this later. But let's say you pick gvisor or Firecracker. You run that locally on your laptop. Like, what if you want to like shut down your laptop and like commute home from work? Or even worse, what if you're a company like Lovable and you're trying to run AI-generated code for tens or hundreds of thousands of users all at once? That's typically when you start needing a sandbox. So let's look at a definition. Sandboxes are ephemeral, isolated environments for running untrusted code at scale. I know that's a mouthful, so if you want a simpler version, you can think of them as computers for agents. And what does a sandbox look like? Obviously, this is hard because it's software, but I'll try to show you. So I mentioned Lovable already. If you've ever used it, you know it looks something like this when you're building an app on Lovable. Lovable is a Modal user, so they use our sandboxes. And so while you're iterating on your code, like over on the left, you can see my prompts here for when I was building this beach-themed game. You also get a project preview that you can interact with, and in this case, play the game. That preview runs in a sandbox. So that's what it looks like, at least if you're building this beach-themed game. But let's go into the definition in a little bit more detail. So ephemeral, like what does that even mean? It's a bit of a hard word. If you look at it like dictionary definition, ephemeral basically means that sandboxes are short-lived. So sandboxes are designed to be very easy and very cheap and fast to spin up. And that sort of comes at the cost of them not being intended to live for very long periods of time. A typical sandbox exists for like a few minutes up to a few hours, although we also have users who run them for like seconds or up to 24 hours. And that means you need to think about how to handle persistence, because if you are, for example, a Lovable user, you may not be like actively vibe coding on your project for more than 24 hours in a row, hopefully not, but you will probably want to come back to it at a later point in time. So there's a few ways that this can be handled. The common ones are external storage or snapshots. So external storage is useful for any sort of artifact that you're generating. So in the Lovable example, that could be your app code. You probably want to store that somewhere outside of the sandbox. You probably want to like git push it like at regular intervals as your agent is making updates to the code. And then when you start a new sandbox later, as you're coming back to this project, you will want to git pull and kind of pull in all that code that you generated. Snapshots are a separate mechanism. They basically allow you to do what it sounds like. You take a snapshot of the entire sandbox and you persist its state. So that could be the file system state, but it could also be memory and persisting like in-memory processes. And that makes it easy to later start a new sandbox from that snapshot and kind of continue where you left off. Next up is isolated. I sort of covered this one already. This is basically the core value prop of using a sandbox at all. You want isolation. You want to keep the agent inside the box. And it's hard. There's a bunch of isolation techniques here that don't work. Docker, I already mentioned, doesn't work for various reasons. Basically, it doesn't give you strong enough isolation from the host where your code runs. Even standard container isolation techniques like runc aren't sufficient for these types of applications that you typically want to run in sandboxes. They're not suitable for multi-tenant environments, like the Lovable scenario. So what's considered best in class is to use technology like gvisor, which is Google's open source technology, or Firecracker, which is Amazon's. There's also a bunch of sort of subvariants of these, and especially of micro-based VMs like Firecracker. But those are considered the best-in-class solutions, and the way they work slightly differently. But gvisor, which is what we use, basically intercepts all syscalls. So that's very hard for an agent to break free from. Next one, scale. I touched on this as well. This is like actually the hardest part of building a good sandbox solution. This is where we spend the vast majority of our time at Modal. So we want the ability, like we have customers on a daily basis running hundreds of thousands of sandboxes, like per user. And we have many of those users as well. So we need the ability to run a lot of sandboxes all at once, and also the ability to scale up and down quickly. There's a few parts of this that are tricky. One of them is the capacity side. We need to get all this capacity somewhere that the sandboxes are going to run on. And so what we do is we buy that capacity off the major cloud providers, but also a bunch of neo clouds. So we integrate with all of these clouds. We want to make sure that our users get the same experience, even though the underlying hardware can differ quite a lot. So a lot of work goes into that. And we want diversity here. So first of all, we don't want to be, like if one cloud provider goes down, we don't want to go down. So we want the ability to shift traffic between them as needed. We also want geographical distribution. That's partially for like compliance reasons. Some of our users need to run in EU or US. And for latency reasons, sometimes you need to run the sandbox very close to your user or close to your control plane. Another aspect is pricing. Like we want to find the cheapest possible capacity. We can generally buy capacity cheaper than any one of our underlying like customers because we can buy a lot more all at once. So we want to kind of benefit from that economy of scale and pass that saving on to our customers. And this is basically a big and tricky problem, and it turns into like this kind of like hairy but fun like math optimization problem. And yeah, we have a whole team at Modal dedicated to just working on this and making sure that we have the capacity we need. And we make these decisions like in real time, like all the time, 24/7. The next problem, once we have the capacity, is like packing the sandboxes, basically figuring out which sandbox goes on which worker. That's tricky too. Sandboxes come in a lot of different sizes and shapes. So this is another sort of tricky math optimization problem that we have a lot of people dedicated to working to. And basically, if we do this wrong, our users end up with like performance problems. So that's obviously important for us to get right, but also to be efficient in. The next problem is observability. Like we need to keep track of exactly how much memory and CPU every sandbox consumes, like by the nanosecond. And that's both because we want to give our users that level of observability, but also because we base our billing on it. So the way we charge like by the actual resource consumption. And that in itself is tricky, just measuring this like at the scale. And that's also something we spend a lot of engineering time on to get this right. And finally, and number 4 is probably the hardest one out of all of these, is the ability to scale up quickly. I'm going to talk a little bit more about like the different use cases we see on Sandboxes in a minute, but one of them is reinforcement learning. And what's unique there is you need to scale up really, really fast. You have these like very bursty rollouts, and that puts a lot of strain on our systems, both on the capacity side, but many other aspects as well. And this is sort of an area where we sort of take pride in, I think, being probably like the provider on the market that's able to scale the best and the fastest, but we're also investing a lot into this and kind of pushing the limits even further. So, as promised, let's talk a little bit about how people use Sandbox in practice. Let's make it a little bit more tangible. So, when I joined Modal, this was in May last year, so almost a year ago, Sandboxes were Modal's like ugly duckling product. I was having conversations with our CEO where I was saying like, why do we have this product? Like, it doesn't make any sense. Like, who uses it? It's like completely disjoint from like our other main business. We're not making any money. Like, who will use this? And he was being like, yeah, maybe we should just like not run this product anymore. And then what happened was the vibe coding platforms took off. So I've already talked about Lovable. We have many other customers similar to them, building similar applications that also run on Modal Sandboxes. And I would say that was like the first use case that really like picked up at scale. Yeah, for all the reasons I've sort of already mentioned. But there's a couple more as well now. But let me just say sort of a few more things about the vibe coding type use case. So the way that a company like Lovable uses Sandboxes is typically to power these project previews that we were looking at before. And they use snapshots to basically pause a project when the user goes idle or goes away, and then they kind of spin it back up again very quickly. The basic architecture is sort of like on this slide. So the LLM itself runs outside of the sandbox, and they have this like agent loop that basically interacts with the sandbox through a tunnel and sends commands and pushes code. The app preview that we were looking at, it also gets served like through a tunnel from the sandbox. But I think the important thing to note here is like the separation, where the sandbox is the execution environment and the agent loop runs outside. And Lovable runs at very large scale. They create something like 1 million sandboxes every day. So you can imagine it's a lot of infra work to be able to make this happen. But then, like while we were, working with all these like vibe coding platforms, another kid on the block came in. I think you have probably all heard about background coding agents. How many of you have heard specifically about ramps? Okay, a few people at least. So Ramp is this American fintech company that blogged in January about how they had built their own internal background coding agent called Inspect. And it's a really good blog post. I recommend, like there's a reason it went viral. They built it on Modal, but they basically go into a lot of depth on like what exactly they built and how. Their observation was basically they wanted to make it much easier for both developers and non-developers to write code and kind of reduce the barrier to kind of getting started and opening PRs. And they didn't find like the sort of options on the market flexible enough. So they wanted to build their own so that it could be adapted to their exact needs. And so what they ended up building looks something like this. So this is different from like the Lovable type scenario because here you have the agent running inside the sandbox. So Ramp uses open code. If you're not familiar, you can think of it as an open source version of Claude Code. So basically the agent runs inside the same environment where it's making tool calls and running the code and making changes. I'll talk a bit more about this later, but this is sort of a fundamentally different architecture and creates a lot of other kind of security concerns than the previous one we were looking at. And then what Ramp does is they integrate with all of these external services, and they end up with this agent that integrates with, a bunch of tools. You can ping it from Slack and say, hey, @inspect, do this thing for me, and it'll open a PR for you on GitHub and kind of send you a link to it. So it's very cool. And they've had a lot of like internal adoption for this. I think this number is probably out of date, but at least half of all their PRs are now written by Inspect, so this internal tool. The last use case, which is actually the biggest one on Modal right now for Sandboxes, is reinforcement learning. This is a screenshot from Devon, built by a company called Cognition. It's one of the major AI labs in SF. You can use Devon to interact with your code base. You can ask it questions. It can review your PRs. It can open PRs for you, similar to the example we just looked at. And Cognition, who builds this, they used Modal Sandboxes when training their software engineering models that power this product. So the way this works in RL is when you're training the model to some sort of coding model, you need a feedback step. So in each step of training, you'll have your model generate code, and you need to execute that code and see what happens. And the result of what happens gets fed back into the training pipeline. So you need a lot of sandboxes. Basically, for every sample that you're running, you will need a sandbox for every step of your rollout. So as I mentioned before, this puts a lot of sort of strain on our systems in a way that we think is like a fun challenge to work with. So Cognition and our other RL users, it's not uncommon that they create sandboxes at something like 300 per second, which is a completely different sort of order of magnitude compared to the other use cases. Few companies like Ramp would need to create 300 sessions per second. So it's a very different use case and sort of requires other things from us. Cool. So I've now given you some examples of what sandboxes are. I hope I've sort of conveyed how, how big and exciting this space is. We've seen an insane traction on sandboxes. I mean, over like the past year, but over the past couple of months in particular, this space really is exploding. And it's an entirely new product category. So like we and everyone else in this space, we're all like learning as we go. We see new use cases pop up all the time, new patterns. We're obviously trying to stay on top of this, but also predict what we think is coming next. So I wanted to touch on sort of 3 trends that we are betting on being the future of sandboxes. So the first one is what I referred to earlier when we were comparing Ramp and Lovable. It's basically, are you running the agent inside the sandbox or outside? So we see both happening today. We strongly believe that sort of the pattern of agent outside is like the way to go for security reasons. If you have the agent inside the sandbox, you end up having to pass secrets, tokens, a bunch of sensitive information into the sandbox. People end up building fairly complex workarounds to make sure that the agent can't exfiltrate your secrets. We think the proper sort of pattern here is actually to run both in sandboxes, but separate sandboxes. So that's what we're building towards. The ability to run the agent in one sandbox and its execution or like its tool calls in another, and have those co-located so that you minimize network latency. So this is our bet on where the world is headed. And the reason that not everyone is already doing this is that basically Claude Code and a lot of these tools, they were originally built under the assumption that you would have the agent running on your laptop. So together with the sandbox or the tool calls itself. And I think even Anthropic is like making some product changes now to make it easier to separate these two. The next one is computer use. We don't see a lot of this today on Model. But one of our co-founders likes to say that like he doesn't want to bet against the major AI labs, and they are investing a lot in this. They're like pouring money into making computer use work well. And so our bet is eventually they will succeed, and we want sandboxes to work really well for these kinds of use cases as well. So that's also an area that we're like predicting will blow up and that we're investing a lot in. The third one I'm excited about. So this one is basically about blurring the boundary between ephemeral containers, so sort of one-time use sandboxes, and persistent containers, so more like traditional VMs. So I've already talked about how you can use snapshots to basically make it easy to stop a sandbox and then start it again from like the same state that you were capturing at the end of the previous sandbox lifetime. But I think there's a lot more that we can do here, and we're working on a lot of stuff here, both to like push down the startup latency of the sandbox and make that like much faster so that it's seamless and you don't perceive that you're having to wait for the new sandbox. But there's also lots of stuff that we can and will do on like the developer ergonomics side that make it sort of feel to you as a developer as if the sandbox is always there, even though actually what we're going to do is like pause it when we notice like there's no activity and then quickly spin it up when it needs to be there again. I'm personally excited about the last one because I think it'll make sandboxes like easier to like understand and use and reason about for a lot of people. And that's it. So I hope I've convinced you that sandboxes are like truly the most exciting AI infra primitive out there right now, and you will only be seeing more of them in like the coming months and years. And if you're as excited about sandboxes as I am, and maybe you want to spend some time on them, not just on weekends, also on weekdays, you should probably check them out or come work with me at Modal. And regardless, I hope that you've learned something that's useful and that you now have the foundations of what sandboxes are and how they can be used. Thank you.
Well, Rebecka, thank you so much for that incredibly interesting presentation. And we have gotten a lot of questions from the crowd here, which is really cool. So the first one is, you noted Docker provides weak isolation, risking container escapes. Why are tools like Firecracker or gvisor better suited for agentic sandboxes? And how do they impact like fast scale-up times?
Yeah, so Docker basically, yeah, as I mentioned, it doesn't give you sort of enough isolation from the host itself. So there's plenty of examples of sort of, yeah, Docker is sort of not even closed. Runc, I guess, is closer, but there's been a lot of sort of vulnerabilities exposed in Runc. So I think that's kind of considered a bad solution as well. What gvisor and Firecracker do is they go one step further. They work slightly differently. So gvisor, as I mentioned, intercepts like all syscalls, and that does add some overhead. Not necessarily in the sandbox startup time. Like it does add some, but the cost mostly comes like as you're interacting with the sandbox. It sort of slows down a little bit. Micro VMs have sort of a different like trade-off profile. They kind of harden the boundary of the sandbox instead. But both are basically considered like safe and isolated enough, whereas like Runc and others are not. I should maybe say like we think those two are like the gold standard like categories of solutions. There are people who disagree. Like there are sandbox providers who pick basically what we consider like weaker isolation mechanisms and kind of in return get faster startup times. And we obviously think that's the wrong trade-off.
Right. Thank you so much. And would you say that the use cases like before the whole vibe coding trend was reinforcement learning, or was there also other use cases back in the day, or was it mostly like the reinforcement learning systems?
Yeah, so reinforcement learning was actually one of the first use cases, though not at like super large scale. One of our very first like large scale users of sandboxes at Modal, and this is before I joined, was Meta. So Meta published a paper on how they used modal sandboxes for like some RL use case. So like I wouldn't say it's new, but it has like exploded in size and popularity over like just the last few months. We're seeing a lot more usage from that recently. But yeah, so RL was like the first, but maybe not the biggest. And the vibe coding was the first one that was like at significant scale and across many users.
And would you say this is right now like your main business, the sandboxes, or?
It's not.
No.
Modal's main business is still the GPU side of things.
Right.
This is like actually, I don't know if I should clarify this or if it's going to just make things more confusing, but you can also run sandboxes on GPUs. But our main business is like serverless functions, so not sandboxes, not assuming sort of AI generated code. And sandboxes are like when you need this isolation and specific containers.
Right. All right, next question. Any suggestions for how to get started with sandboxes for code execution agents in products?
Yeah, so it depends on what you want to do. I mean, you can definitely use like an out-of-the-box solution, like I think Cursor and Anthropic and all of these, they offer that, and you don't need to think about the sandboxes yourself. If you want to build your own, the RAMP blog post, I would definitely recommend. Like they talk a lot about like all the decisions they had to make and the trade-offs involved. I would definitely recommend using open code for the agent itself. It's super useful. It's a great open source framework. In general, for getting started with sandboxes, I really think it depends on your use case. It depends on what you're trying to achieve. Like, you should pick something that's similar to the use case you're interested in working on, because it's obviously a very different thing to use sandboxes for like an RL rollout versus a background coding agent.
Thank you. Last question. Do you create like separate sandboxes for each of the use cases that you mentioned, or is it possible to have like more general sandboxes that works well in all kind of use cases and areas?
Yeah, so this is all controlled by the user, not us. So they define like which sandboxes they want created. The difference obviously is like the image they will use. They will definitely use very different images for these different use cases, and we try to make that very, very easy to run on custom images. There are some other providers that kind of give you like pre-built images for specific use cases. We don't, because we don't really believe in that approach. We believe more in making it very easy to customize and build your own image or grab it from like an external registry if you already have one there. And then once the sandbox has been created from an image, like obviously there's a lot more that happens. You'll, pull files, or you'll do a git pull, you'll start a server, like there's all kinds of things you might want to do here. And at this point, the sandbox is becoming very like customized to your use case, but this is all like done by our user, not us. So we don't have like pre-defined sandboxes for RL or background coding agents. That's on the user. What we do is we provide a lot of examples. Like We have, if you're interested, like we have hundreds of examples on our docs where we basically try to show how different things can be done. So we do that rather than pre-package solutions.
Wonderful, thank you. That's time's up, and as a thanks, we want to give you a big applause, and we also want to give you this umbrella. And thank you so much for being here.
Thank you so much.